Hello viewers, welcome to my channel and thank you for watching the videos. In this video, question 7b of 1992 analytical geometry show that the locus of the foot of the perpendicular from the center to the plane through of three conjugates of the ellipsoid x square upon a square plus y square upon b square plus z square upon c square is a square x square plus b square y square plus c square z square is equal to 3x square plus y square plus z square. So this question may be asked in this form also. Prove that the locus of the foot of perpendicular from the center of the ellipsoid x square upon a square plus y square upon b square plus z square upon c square is equal to 1 on the plane PQR is this expression which we have written here. So before going to question, I would like to say a few points that we need to know the relationship between the coordinates of the point PQR where OP, OQ, OR are the conjugate semi-diameters of the ellipsoid. So as we said that ellipsoid is x square upon a square plus y square upon b square plus z square upon c square, and PQ are the points, 3 points. P is x1, y1, z1, Q is x2, y2, z2, and R is x3, y3, z3. And of course origin is there. So OP, OQ, OR, we can have these points. So these 3 points will lie on the ellipsoid. It means they will satisfy this equation that x square upon a square plus y square upon b square plus z square upon c square is equal to 1. So x1 square upon a square plus y1 upon b square plus z1 upon c square is equal to 1, and similarly for x2, y2, z2 and x3, y3, z3. And we know that the diametral plane of any one of OP, OQ and OR passes through the extremities of the other two, and therefore we have this expression x1, x2 upon a square plus y1, y2 upon b square plus z1, z2 upon c square is equal to 0. And similarly x2, x3 upon a square plus y2, y3 upon b square plus z2, z3 upon c square is equal to 0. And third one will be x3, x1 upon a square plus y3, y1 upon b square plus z3, z1 upon c square is equal to 0. And we know that if LMN are the direction cosines of any line, then we know that L square plus M square plus N square is equal to 1. In this way we can write down that x1 upon A, y1 upon b, z1 upon c, and x2 upon a, y1 here y2 upon b, z2 upon c, and for third x3 upon a, y3 upon b, z3 upon c. These are also direction cosines of some three lines. And if we know that L1, M1, N1 and L2, M2, N2 be the direction cosines of two perpendicular lines, in that for perpendicular lines we can write L1, L2 plus m1 m2 plus n1 n2 is equal to 0. And it means in this way we can say that the three lines are mutually perpendicular. If we are taking L1 M1 N1, L2 M2 N2, N3, for third one is L3 M3 N3. And of course similarly x1 upon a, y1 upon b, z1 upon c, these are also perpendicular to each other. And also we know that L1 M1 N1, L2 M2 N2, L3 M3 N3, these are direction cosines of three mutually perpendicular lines. Then we can say that L1 L2 L3, M1 M2 M3, N1 N2 N3 are also direction cosines of three lines which are mutually perpendicular. So in that case we can write L1 square plus L2 square plus L3 square is equal to 1 and so on. And similarly L1 M1 plus L2 M2 plus L3 M3 is equal to 0, etc. and so on, or etc. So in this way we can write down, as we have written here, that we are taking now L1, L2, L3. So we can take x1, x2, x3. So x1 square plus x2 square plus x3 square is equal to a square. Because this is x1 square upon a square plus x2 square upon a square plus x3 square upon a square is equal to a square. And y1 square plus y2 square plus y3 square is equal to b square. And z1 square plus z2 square plus z3 square is equal to c square. So we also have x1 upon a, y1 upon b plus x2 upon a plus into y2 upon b plus x3 upon a, y3 upon b is equal to 0. And from here we can have AB cross multiplication. It will imply x1 y1 plus x2 y2 plus x3 y3 is equal to 0. And we will be having y1 z1 plus y2 z2 plus y3 z3 is equal to 0, z1 x1 plus z2 x2 plus z3 x3 is equal to 0. So these will be the case. Now we come back to the question, and we said that there is a plane. Plane is Lx plus My plus Nz is equal to P. So this is first case. Still we are doing one equation derivative. Then we will take that equation to solve the question. And let the center of the plane is O. O is the center of the plane. And center of plane and ellipsoid is same, that is O. And since this plane passes through PQR, it means PQR are satisfying this equation. It means Lx1 plus My1 plus Nz1 is equal to P. Then Lx2 plus My2 plus Nz2 is equal to P. Lx3 plus My3 plus Nz3 is equal to P. Now we multiply first equation by x1, this one by x2, and this is by x3. So from first term we get Lx1 square, first for each, this term, plus x2 square plus x3 square plus m into y1 x1. So this will be x1 y1 plus x2 y2 plus x3 y3 plus n x1 z1 plus x2 z2 plus x3 z2 z3 is equal to p x1 plus x2 plus x3. x1 square plus x2 square plus x3 square is equal to a square. So L into a square m into 0 plus n into 0 is equal to p x1 plus x2 plus x3. It gives L is equal to p x1 plus x2 plus x3 upon a square, and m is equal to p upon b square y1 plus y2 plus y3, and n is equal to p upon c square z1 plus z2 plus z3. So when we put L value, m and n value in Lx plus my plus nz is equal to p, we get the equation x upon a square. P will cancel out on both sides. x1 plus x2 plus x3 plus y upon b square y1 plus y2 plus y3 plus z upon c square z1 plus z2 plus z3 is equal to 1, and this is the equation of plane PQR. Now we got this. It means now we take suppose n denoted by alpha, beta, gamma be the foot of perpendicular from the center 0 0 0, that is O, to the ellipsoid perpendicular from the center O 0 0 0 of the ellipsoid to the plane PQR. Then what happens? Let P is the length ON, and 0 0 0 is one point, alpha, beta, gamma is another, so this is the length. Now DCs of the ON, the normal to the plane PQR are alpha upon under root alpha square plus beta square plus gamma square, and beta upon under root alpha square plus beta square plus gamma square, and gamma upon under root alpha square plus beta square plus gamma square. These are the DCs, which we can write down alpha upon P, beta upon P, and gamma upon P, because we know this is P. We can write this way. The equation of the plane, hence the equation of the plane PQR is also given by alpha upon px plus beta upon py plus gamma upon pz is equal to 1, which is alpha x plus is equal to p alpha x plus beta y plus gamma z is equal to p square. Now we compare this equation and the equation we got here. Let's say A and B. When we compare A and B, it gives x1 plus x2 plus x3 upon A square upon alpha. And this will be is equal to y1, or you can say y1 plus y2 plus y3 upon b square beta, and z1 plus z2 plus z3 upon c square gamma is equal to, all of them are equal to 1 upon p square. So we can write down x1 plus x2 plus x3 upon a is equal to a alpha upon p square, y1 plus y2 plus y3 upon b is equal to b beta upon p square, and z1 plus z2 plus z3 upon c is equal to c gamma upon p square. Now we square them and add. Squaring and adding. It gives sigma x1 square upon a square. Means we are squaring x1 plus x2 plus x3 square upon a square plus sigma y1 square upon b square plus sigma z1 square upon c square plus twice of sigma x1 x2, when we will multiply the terms, x1 x2 upon a square plus twice of sigma x3. It will be covering y1 y2 also, z1 z2 also. So twice sigma x3 x1 upon a square plus twice sigma x2 x3 upon a square. So this gives, we can write here a square alpha square upon p4, p square whole square, p4 plus b square beta square upon p4 plus c square gamma square upon p4, which is equal to, this is the left hand side and this is right hand side. We are writing only this equation, squaring and adding. So this is left hand side, this is right hand side. Now left hand side gives 1 plus 1 plus 1 plus all 0 is equal to this right hand side, this value whole right hand side, and we get 3 If we cross multiply, 3p to the power 4 is equal to a square alpha square plus b square beta square plus c square gamma square. And this is what p is, what we have to write the value of p. So we had 3p to the power 4 . So we had 3p to the power 4 is equal to a square alpha square plus b square beta square plus c square gamma square. And p we know under root alpha square plus beta square plus gamma square. So this will become 3 of alpha square plus beta square plus gamma square whole square is equal to a square alpha square plus b square beta square plus c square gamma square. Now we take locus of alpha beta gamma. So that will be 3x square plus y square plus z square whole square is equal to a square x square plus b square y square plus c square z square. And this is what we wanted to prove. Thank you.